Good evening, dear students. So, yes, so yesterday we have completed the chapter aldehyde, ketones, and carboxylic acid. Right, so today we are going to start with a new chapter. So, today we are going to see the chapter, the name of the chapter which we are going to see is amines. Okay, so what do you mean by amines? Yes, what do you mean by amines? So amines, okay, so these are the derivatives of ammonia. So they come from ammonia, okay, so we called it as they are the derivatives of ammonia, okay. So what is the formula of ammonia? It is NH3, okay, it is NH3, ammonia, okay. So here what we are doing, so either one or two or three, all the three hydrogen atoms of the ammonia, they are replaced by a alkyl or a aryl group. Okay, so then we give rise to amines. So what are amines? Basically, so amines, these are the derivatives of ammonia, okay, in which one or two or all the three hydrogen atoms, they are replaced by alkyl or the aryl group. Now you know what is an alkyl group and what is a aryl group. So alkyl means what? Suppose I have a methane, okay, CH4. So if I remove one of the hydrogen, okay, so it becomes CH3. So methane, okay. So what I am doing? I am replacing NeAne by Yl. So it becomes methyl. Okay. Similarly, the other this also the compounds they are said like that. Okay. So ethane, so one hydrogen is less and you call it as ethyl. Propane. Okay. Remove one hydrogen. Okay, and replace Ane by Yl. It becomes propyl, butyl, pentyl, hexyl, etc. So that is alkyl. And aryl means what? When you have an aromatic ring. Okay, when you have an aromatic ring, that is a benzene or the benzene derivatives. Okay, so then you have aryl group. So amines. So we will see what are amines. So amines are what we have said. So they are the derivatives of ammonia in which one, two, or all the three hydrogen atoms they are replaced by alkyl or a aryl group. Okay, I hope the definition is clear. Okay, so here you can see basically, okay, so they are the molecules of ammonia, okay, where one or two or three, all the three hydrogen atoms are replaced by alkyl or a aryl group. Okay, so this is a definition of your amines. Okay, next we are going to see the classification. Okay, how they are further classified. Okay, how they are classified. So amines are basically classified as primary amines, okay, secondary amines, and tertiary amine. So basically, what amines, how they are classified? They are classified as primary, secondary, and tertiary. So we will see each term, okay. So what do you mean by primary amines, students? Yes, what do you mean by primary amines? So here, only one of the hydrogen atom, okay, one of the hydrogen atom of ammonia. So now we have seen what is ammonia. So this is ammonia, okay, NH3. So one of the hydrogen atom, okay, of the ammonia, okay, so that is replaced by what? That is replaced by your, it is replaced by your what? Alkyl group. Okay. It is replaced by the alkyl group. Okay. So then it is called as what? Primary amine. So only one hydrogen atom, when it is replaced by one what alkyl group, then it gives rise to primary amine. Okay. Similarly, again, so the replacement of two hydrogen atom, okay, replacement of two hydrogen atom, okay, by alkyl group, okay, by alkyl, or you can take aryl group. It can be a alkyl group or it can be a aryl group. Then it gives rise to a secondary amine. Okay, it gives rise to secondary amine. Okay, so I'll repeat it once again. Okay, so classification, we are discussing about the classification of amines. So when we are discussing about classification of amine, so amines are basically classified as primary amine, secondary amine, and tertiary amine. So what do you mean by primary amine? In primary amine, when you see the structure of ammonia, so one of the hydrogen atom is replaced by the alkyl or a aryl group. Okay, then it is called as a primary amine. Okay, so this is a primary amine. So we are generally representing the primary amine as RNH2. Okay, RNH2. Okay, so here the functional group is the amino group. The functional group is the amino group. Now, second one is, okay, so second one is the secondary amine. So what we have discussed about secondary amine. So when two hydrogen atoms, so here is the ammonia. Okay, so when two of the hydrogen atoms are replaced by a alkyl or a aryl group, okay, then they are called as the secondary amine. Okay, they are called as what? They are called as the secondary amine. So replacement of two hydrogen atom, they are called as the secondary amine. Is it clear? Yes. Okay. So now here, what is the general represented? It is generally represented as R, NH, R dash. Okay. R, NH, R dash. Okay. So this, the functional group is imino. It is called as imino. Okay. The functional group is imino. IMINO. Okay. So let us give now the examples for primary first amine. Okay, primary amine, I'll give you the example like methylamine. Okay, CH3 and H2. So the name is methylamine. So this is a alkyl amine. So if I give you an example for a aryl amine, so this is NH2. So with a benzene ring, okay, NH2 is attached to a benzene ring. So this name is aniline. Okay, so this is example of, both are the examples of primary amine. Now let us see the examples of secondary amine. So CH3, NH, CH3. Okay, so this is example of secondary amine. Okay, and one more example I'll give. So please tell me the name. Can anybody tell the name of this compound? Yes, first and second. So this is, okay. So this is what? 1, 2. So it is a dimethylamine. So the name is dimethylamine. Okay, and this, what is the name of the second compound, the aromatic compound? It is methyl phenylamine. Okay, it is methyl phenylamine. Understood? Okay, so we have seen what is primary amine, what is secondary amine. Okay, and we have seen the example. Now, next, let us go for tertiary amine. Okay, next, let us go for tertiary amine. So, what do you mean by tertiary amine, students? So, here, when we are writing the structure, okay, when we are writing the structure of ammonia, so when what you can see that, what you can say, all the three hydrogen atoms are replaced by a alkyl or a aryl group. Okay, it is replaced by a alkyl or a aryl group. Then they give rise to what? Tertiary amine. Okay, and what is the functional group? The functional group is the, like this. Okay, it is represented like this, functional group. Okay, so that is it is a tertiary nitrogen is present here. Okay, it is the nitrogen. It is tertiary in nature. Okay, and what is the example? Okay, let me give the example. So CH3N, CH3 and CH3. So one example of alkyl, and let me give the example of a aryl amine. Okay, so N, CH3 and CH3. Can you give the names? Yes, can anybody give the names? So the names, okay. So this is 1, 2, 3. So 3 methyl groups. So it is trimethylamine. Okay, it is a trimethylamine. And what is the name of this? It is dimethyl phenylamine. Okay, dimethyl phenylamine. Is it clear? Okay, so these are the names. Okay, so we have seen what is primary amine. Okay, we have seen what is secondary amine. Okay, and we have seen what is tertiary amine. I hope you have understood it. Okay, so further, these amines can also be classified as simple, okay, and mixed. Okay, now what do you mean by simple? Simple means when you have all the alkyl or the aryl group same. Okay, same alkyl or aryl group is present, then it is called as simple. And mixed means what? When you have different, okay, when you have different alkyl or aryl groups, and they are called as mixed amines. Is it clear? Okay. So next we are going to see the nomenclature. Okay, nomenclature means how to name these amines. Okay. So in IUPAC system, when you see the IUPAC system, okay, so aliphatic amines are named as alkanamines. What they are named as? They are named as alkanamines. Okay. So in IUPAC system, the amines, they are derived as alkanamines. Okay. And in case of aromatic amine, okay, in case of aromatic amine, the simplest member is your C6H5NH2. That is aniline. Okay, so this is the simplest member of your aromatic amine. That is aniline. Okay, and this is also accepted as a IUPAC name. Okay, or it is written as benzene amine. Okay, your E is replaced by amine, benzene amine. Okay, E is replaced by amine. Okay. So E alkanamine. So E of the alkane is replaced by amine. So like this, you are going to name the compound. Is it clear? So in IUPAC system, amines are named as alkanamine. So E of the alkane is replaced by amine. Okay. Yes. So let us see examples. So here you can see CH3NH2. Okay. So CH3NH2 is methane. Okay. Methanamine. The name is methanamine. Okay. Now let us see this name. So one, 2, 3. Okay. What is the name? What is the name? It is propane. Okay. At propane, because 3 carbons are there. So propane. And at second position, you have amine. So 2 amine. So propane 2 amine. Now here you see. So first, second, third. So add. So what you have here? So it will be like this. CH3, NH, CH2, CH3. So how we are going to name this compound? It is NN dimethyl ethanamine. Okay, NN dimethyl N-methyl. Okay, N-methyl ethanamine. Okay, N-methyl ethanamine. Okay, let us go for the next one. Okay, next one. So this is NCH3, CH3, and CH3. Okay, so the name is what? N dimethyl methanamine. Okay, then here this is aniline, and this is 1, 2, 3, 4. So 4 bromoaniline. So like this, you're going to name the compounds. Then this compound, how you're going to name the compound? So 1, 2. Okay, so at 2 position, you have phenyl group. So 2-phenyl ethanamine. Okay, then here 1, 2, 3, 4, 5. So NN diethyl butane 1 amine. Okay, so like this you're going to name. So this is the IUPAC nomenclature. Okay, you have to follow the rules and name the compound. So next we will see, before going to the preparation of amines. So first let us see the structure of amine. Okay, let us see the structure of amine. So let me write the structure of amine here. So amine, okay, so we will see CH3, CH3, CH3. Okay, so here what you can see, so there is a lone pair present here. So let me explain this now. Okay, so what you can see here, okay, now here, so when you see this is a amine, Okay, so in amine, the site there is in central what is present, nitrogen is present, and this nitrogen is what? It is sp3 hybridized because the bonds are single bonded. So this nitrogen is sp3 hybridized. Okay, so this is sp3 hybridized. Okay, and it will give you four hybrid orbitals. They will give you what? Four hybrid orbitals, nitrogen. Okay, 1s2, 2s2, 2p, 3. Okay, so I'm going to get what? So I'm going to get four hybrid orbitals. Okay, so I'm going to get four hybrid orbitals. So out of this four hybrid orbitals, okay, so out of this four hybrid orbitals, what will happen? Three hybrid orbitals, they form sigma bond. Okay, they form sigma bond. Okay, with the your hydrogen atom, and that is alkyl or aryl group. And the fourth hybrid orbital, it contains this lone pair of electron. It contains what? The lone pair of electron. Okay, and thus because of this, they are having the which shape? It is having a pyramidal shape. Okay, it is having a pyramidal shape. Okay, it is having the pyramidal shape, and the bond angle is less than 109.5. Okay, that is 108. The bond angle is less than 105. That is 105.5 degree. That is, it is 108. Okay, so this is the structure of your amine. Is it clear? Okay. So let us start with the preparations. So first one is by reduction of nitro compounds. Okay, by reduction of nitro compounds. So what we can do here, we can easily reduce the nitro compounds, okay, but to primary amine. So nitro compounds are directly reduced to amines by using various reducing agents. So which can be the reducing agents which we can use? So reducing agents like your tin HCl, okay, like tin HCl, then FeHCl, okay, or you can use catalytic hydrogenation, okay, you can use catalytic hydrogenation, which is catalytic hydrogenation, like your hydrogen, nickel, okay, platinum, palladium, okay. So these are the different reducing agent which you can use, okay. So what I am doing, so I have, so I will give you a general reaction plus RNO2, okay. R can be any alkyl or aryl group in the presence of tin HCl, okay, in the presence of tin HCl, concentrated HCl, or you can use FeHCl. What I am going to get? RNH2. Okay, I'm going to get RNH2. I'm going to get a primary amine plus water molecule. Okay, plus water molecule. So based on that, first example, this is a nitrobenzene. Okay, nitrobenzene in the presence of tin HCl and concentrated HCl. I'm going to get a aniline. Okay, I'm going to get a aniline plus 2H2O. Okay, one more example I would like to give. So the example is with respect to alkylamine. So CH3, CH2, and NO2. So what will be the name, students? What will be the name? The name is what? It is a nitroethane. Okay, it is nitroethane. So nitroethane, when it is heated with what? Nitroethane. Ethane is heated with your tin HCl. Okay, in the presence of tin HCl, what I'm going to get? I'm going to get CH3, CH2, NH2. That is nitro. It is ethanamine. Okay, it is ethanamine. Okay, so this is the reaction. So we are reduction. We are doing reduction. So how we can do reduction? By using the reducing agent. So which are the reducing agent? Like tin HCl, FeHCl, or you can do catalytic hydrogenation. That is by passing hydrogen over nickel, platinum, or palladium. Is it clear? Okay. So next is reduction of nitriles. Okay, next is reduction of nitriles. So we can reduce the nitriles. I hope you know nitriles. Nitriles means cyanides. Okay, or you can say nitriles. So cyanides or nitriles. Okay, so these nitriles can be reduced to primary amine. Okay, it can be reduced to So this can be reduced to primary amine, okay, by using a strong reducing agent like lithium aluminum hydride, okay, or you can use sodium in alcohol, okay, by using lithium aluminum hydride or using sodium in alcohol, okay, or you can also use catalytic hydrogenation, or you can also use catalytic hydrogenation. So you will get primary amine. So you are going to get what? Primary amine. So from nitriles or cyanides, you can easily do reduction by using lithium aluminum hydride or sodium in alcohol, or you can also use catalytic hydrogenation, that is by passing hydrogen over nickel, and it produces your primary amine. Okay, it produces primary amine. So let me give you example. So RCN in lithium aluminum hydride over dry ether giving you methanamide. So first example, CH3CN. What is the name of this? It is ethane nitride. Okay, it is ethane nitride. React it with lithium aluminum hydride. What I'm going to get? I'm going to get CH3, CH2, NH2. Okay, I'm going to get CH3, CH2 and NH2. What is the name? Ethanamine. Okay, I'm going to get ethanamine. So ethane nitrile with the help of lithium aluminum hydride will give you ethanamine. One more with respect to aryl group. Okay, I have what? Benzyl nitrile. I have benzyl nitrile. This benzyl nitrile again, what I'll do, I'll pass hydrogen gas over nickel get nickel. Okay, so what I'm going to get? I'm going to get CH2 and H2. I'm going to get 1-phenyl methanamide. 1-phenyl methane amine. Okay, so these are the two examples of reduction of nitriles. So nitriles can be reduced with lithium aluminum hydride or sodium in alcohol, or you can do catalytic hydrogenation and produces primary amines. Is it clear? Okay. Next question. Next, we are going to see reduction of amides. Okay, next we are going to see the reduction of amides. So acid amides, so these are the acid amides. So these acid amides, we are going to do reduction with lithium aluminum hydride. Okay, and I'm going to get a primary amide. Okay, I'm going to get a primary amide. So lithium aluminum hydride, so we are doing reduction of amide. So acid amide is used. So this acid amide, when it is heated, okay, with lithium aluminum hydride, it gives you primary amide. Okay, yes. So let me give an example. I'll take this as acetamide. Okay, in the presence of lithium aluminum hydride and water. What I'm going to get? I'm going to get CH3, CH2 and NH2 plus water. So this is primary amine. Is it clear? Okay. So CH3, CH2, NH2. So that is a ethanamine. The name of the this is ethanamine. Okay. Yes. So acetamide reacting with on reduction with lithium aluminum hydride will lead to amines. Okay. Yes. So one more example I'll give you. So we have seen for acetamide, no? Okay, fine. So next is Hoffmann bromamide degradation reaction. Very, very important. Hoffmann bromamide degradation reaction. Mark this as very important. Very, very important. So mark this as very, very important. Okay, this is very, very, very important. So what we are doing here, we are taking acetamide. Okay, we are taking acetamide and this acetamide. So what we are going to do? We are going to treat it with bromine. Okay, in aqueous or you can take ethanoic NaOH. You can take either aqueous or you can take ethanoic. Okay, or you can take ethanoic NaOH or you can use KOH also. Okay, you can use NaOH or you can use KOH also. Okay, and what it gives you? It gives you primary amine. So acidamide, you're going to treat it with aqueous, or you're going to treat it with bromine in aqueous or ethanoic, KOH or NaOH, and it gives you primary amines. Okay, and this amines which is formed here, no, it has one carbon less than that of the parent compound. Okay, so here the product whatever is formed, it has one carbon less, okay, than the parent amine, and thus these reactions are called as a degradation reaction. They are called as degradation reaction. Okay, they are called as what? They are called as degradation reaction. So why? Because acid amide, we are heating it with bromine in the presence of aqueous or ethanoic, NaOH, or you can use KOH to give you primary amines. These primary amines are having one carbon atom less than that the parent amine. Okay, yes. So this is the general formula. So amides reacting with bromine in the presence of NaOH, heat it. I'm going to get a primary amine, Na2CO3, NaBr plus 2H2O. So I'm going to get a primary amine. So similarly, let me take an example of benzamide. Benzamide reacting it with Br2, okay, in the presence of NaOH. What I'm going to get? Aniline plus Na2CO3 plus NaBr plus 2H2O. Okay, very, very important. Hoffmann bromide degradation reaction. Very, very, very important. Okay. Next, we are going to see is the uh, ammonolysis. Okay, next we are going to see is the ammonolysis. So what we are doing in ammonolysis, so alkyl halides are taking, so this is the alkyl halide. These alkyl halides, they are heated with ethanoic NH3. So this is a ethanoic NH3, okay. And what is happening, which under a sealed vessel, okay, at 373 Kelvin. So what is happening there? Successfully, okay, at each step, successive step, what is happening? There is a replacement of hydrogen atom of this NH3 by alkyl or a aryl group. Okay, and those primary, secondary, or tertiary amines are formed. Okay, and at last, quaternary ammonium salt is formed. So this reaction is called as ammonolysis. What is called as ammonolysis? Okay, so alkyl halide, it is treated with what? Ethanoic, KOH, ammonia in a sealed vessel. Okay, at 373 Kelvin. So after successive replacement of hydrogen atoms of ammonia by alkyl or aryl group takes place. Okay, and it forms primary, secondary, and tertiary amine. And finally, a quaternary ammonium salt is formed, which is called as the ammonolysis. So here you can see the reaction. So Rx plus NH3, you'll get RNH2. Further reacting again with Rx, you are going to get R2NH. Again reacting with alkyl halide, I am going to get R3N. Okay, and then finally, I am going to get the quaternary ammonium salt. That is R4N plus X minus. So primary, secondary, and tertiary amine. Is it clear? So the process of cleavage of CX by ammonia molecule is called as ammonolysis. Okay. The primary amine thus obtained behaves as a nucleophile and can further react with alkyl halide to give secondary and tertiary amine, and finally quaternary ammonium salt. So it gives you the mixture of primary, secondary, and tertiary amine. Okay, but however, the major product will be your primary amine. Okay, yes. Okay, fine. Let us go for the next one. Next, we are going to see the Gabriel phthalimide synthesis. Okay, next we are going to see the Gabriel phthalimide synthesis. So mark this also very, very important. Gabriel phthalimide synthesis, students. Mark this as very, very, very important. Okay. Yes. So this is also used for preparation of aliphatic primary amines. Okay, they are used for the preparation of aliphatic primary amines. Okay, so what we are doing, we are taking a phthalimide. This phthalimide, it is treated with potassium, ethanoic potassium, this what, hydroxide, and I'm going to get a potassium salt of phthalimide. So this is potassium salt of phthalimide. Okay, this is potassium salt of phthalimide. This potassium salt of phthalimide is further heated with alkyl halide. It is heated with alkyl halide. So what is happening? It forms N-alkyl phthalimide. It forms N-alkyl phthalimide. This N-alkyl phthalimide, okay, further undergoes hydrolysis Okay, further undergoes hydrolysis to form N-alkyl phthalimide. Okay, it forms N-alkyl phthalimide. Okay, then you are going to get what? On hydrolysis, N-alkyl phthalimide gives primary amine. So this will give you primary amine. Okay, so these are the steps. So phthalimide, reacting it with alcoholic AOH to give you the potassium salt of phthalimide. This potassium salt of phthalimide further reacts with the alkyl halide and it forms N-alkyl phthalimide. Okay, and this N-alkyl phthalimide further reacting, we are going to get primary amine and sodium phthalate. Okay, sodium phthalate. Yes. Okay. So by this method, from Gabriel phthalimide synthesis, you cannot prepare aromatic primary amines. You can only prepare primary amines. Is it clear? Okay. Okay. Let us go for the next one. So here you can see, okay, so here they have taken phthalimide. This phthalimide is reacted with ethanoic KOH. What is happening? I'm going to get a potassium phthalimide, salt of solamide. This reacts with alkyl halide. I'm going to get N-alkyl phthalimide. This N-alkyl phthalimide, when you react it with what? An alkyl phthalimide reacted with your this an alkyl phthalimide. Okay, reacted with NaOH. Okay, reflux it. I'm going to get what? I'm going to get the sodium phthalate and primary amines. Okay, so this is the reaction. So aromatic primary amines cannot be prepared by this method. Okay, yes. So next we are going to see the physical properties. Okay, next we are going to see the physical properties. So when we talk about the physical state, okay, and odor, your aliphatic amines, which are lower, they are gases and they are having fishy odor. Okay, they are having fishy odor. And primary amines with three or more carbon atoms, they are liquid. Okay, carbon, your primary amines with three or four carbon atoms, they are liquid and they are solid with ammonia smell and they are solid with ammonia or solid with ammonia smell. Okay, is it clear? So lower aliphatic and amines are gases that gives fishy odor. Okay, so primary amines or what? This. So primary amine with three or more substance carbon atoms are liquid or solid with ammonia smell. Okay, next we are going to see the solubility. So lower aliphatic amines, they are soluble in water. Okay, the lower aliphatics, these are soluble in water because they form hydrogen bond. Because of the hydrogen bond, they are soluble in water. Okay, so as the size increases of the hydrophobic alkyl part, solubility decreases. So as the hydrophobic part increases, the solubility will decrease. So when you see in alcohols, hydrogen bond are more, okay, as compared to that of amines. So as compared to the alcohol, amines has lesser, what is that? Lesser solubility. Okay. So alcohols, hydrogen bonds are more stronger than amine. In alcohols, the hydrogen bonds are more stronger than amine. Okay. And thus alcohols are more soluble than your primary amines. So when you see butane 1 all and butane 1 amine, butane 1 all, that is alcohol is soluble in water, then your amine. Okay. Yes. Next, we are going to see the uh, next is the boiling point. Okay, next is the boiling point. So next, let us see boiling point. So primary and secondary amines, they show intermolecular hydrogen bonding. Okay, intermolecular means within different molecules. Okay, so this intermolecular association is more in the primary than in secondary. So as you see the intermolecular association, it is more in primary than secondary. Okay, but when you see tertiary amines, due to the absence of hydrogen, there is no intermolecular association. So the boiling point of the amines is primary is greater than secondary, which is greater than tertiary. Okay, yes, fine. Next, we are going to see the chemical properties. Okay, next we are going to see the chemical properties. The first one is the basic character of amines. First one is what? Basic character of amines. Okay. So amines basically, when amines they are basic in nature, they react with acid and they form salt. Okay, as you know, acid and base react to give you salt and water. So amines, as we say, they are basic in nature. They react with the acid. They form salt. Okay, they form ammonia salt. Okay, which so this indicates that the amines are basic in nature. So RNH2. Okay, RNH2, this reacts it with your acid and you are going to get RNH3 plus X minus. Okay, plus X minus. Okay, so here this is the base, this is the acid, and this is the salt. Okay, then so because of the lone pair of electrons, okay, on nitrogen, nitrogen has a lone pair of electron. They act as what? They act as a Lewis base. They act as Lewis base. Okay, so when they are dissolved in water, they produces OH minus ions. Okay, they produces OH minus ions. Okay, so this is the definition of basic character of amines. Okay, fine. So aliphatic amines, okay, when you see aliphatic amines, they are stronger than ammonia due to plus effect. So amines count the number of carbon directly attached to the nitrogen. So here how many carbon atoms are directly attached to nitrogen? So here one, there is no carbon atom, so zero. So here two carbon atoms. So 1, 2, and 3. Here 1, 2, 3, and 4. Okay, so these are the number of carbon atoms attached. Now, so primary is unique. Primary ammonia is unique primary amine, secondary amine, tertiary amine, and quaternary ammonium amine. So next we will see basicity of aromatic amines. Okay. So aromatic amines, they are less basic than aliphatic amines and ammonia. The reason is the lone pair of electrons on the nitrogen atom is delocalized into the benzene ring. Okay. So as a result, what happens? The lone pair of electron is available for ammonia. Okay. There is a lone pair of electrons which are available for the ammonia. Okay. So these are the basicity of primary, secondary, tertiary amine due to plus I effect. So primary is greater than secondary and tertiary due to solvation. Primary is greater than tertiary and secondary and tertiary. And steric factor, primary is greater than secondary and tertiary. Okay. So this is the actual order. Okay, this is the actual order. So you can see that CH3 group is having the less steric hindrance. Okay, as compared to the other atoms. Okay. Okay. Next, we are going to see the reactions. Okay, so we are going to see the alkylation, acylation. Okay, what is alkylation, what is acylation? So alkylation means what? Okay, alkylation, yes, what is alkylation, what is acylation? So amines, yes, so amines, okay, they react. Amine is RNH2. Okay, they react with excess of alkyl halides. Okay, they react with excess of alkyl halide. Okay, in the sealed tube. So what is happening at each step? There is be replacement of hydrogen atoms by the your alkyl group. Okay, and thus primary, secondary, and tertiary, and finally quaternary ammonium salt is present. So it is R2NH. So this is secondary. Again, you react it with Rx, I'm going to get R3N. Again, you react it with R4N plus X minus. So it is what? It is quaternary ammonium salt. Okay. So primary amine, secondary and quaternary ammonium salt. So from tertiary to quaternary ammonium salt. Okay. So this is alkylation. So amines, they react with excess of this alkyl halide. Okay, and replacement at each step, hydrogen atom of NH2 group, okay, by the alkyl group, and it forms secondary, tertiary amines, and at last it is giving you a quaternary ammonium salt. So this is about alkylation. Let us go for acylation. So acylation is what? So primary and secondary amines, okay, they are treated with acid chlorides. Hmm. I hope you know what is acid chloride now, and esters also. And what happens? The hydrogen atom of this NH2, okay, it is replaced by the acyl group, and it forms N-substituted amines, okay, amides. So this reaction is called as the acylation. This is called as what? Acylation. So here you can see. Yes. Okay. So here we are. So just now what all we have discussed? We have discussed about the alkylation and we have discussed about the acylation. Okay. So what is the difference? In alkylation, we are treating it with excess, okay, of alkyl halide. Okay. And then at each step, there is a replacement of hydrogen atom, okay, by the NH2 group. Okay. So the replacement of hydrogen atom of NH2 group by the alkyl group. Okay, and it forms secondary, tertiary, and finally the quaternary ammonium salt. Now, when you are seeing acylation, what happens in acylation, students? Yes, in acylation, what is happening? Primary and secondary amines we are going to treat. So, let me give an example, then you'll come to know. Okay, so this is what is the name of this? This is ethyl group. So, it is a ethylamine. Okay, it is a ethylamine. React it with a acid chloride. So let me take a acetyl chloride. So this lone pair will attack the carbonyl carbon. And what I'm going to get? So this occurs in the base, presence of base like pyridine. I'm going to get C2H5. Okay, NH, then C double bond O, CH3 plus HCl. So I'm going to get N-ethyl. Okay, N-ethyl ethanamide. Okay, and ethyl ethanamide. Okay, so like this. So these are the example. One more example I can take C2H5, C2H5 and H plus acetyl chloride. Try, try to answer. So again, this will in the forms of pyridine. What I'm going to get? So C2H5, H, C2H5, C double bond O, CH3. Okay, so this is NN diethyl ethanamide. Okay, ethanamide. Fine. Okay. So one more example I can give you. Aniline. Take aniline. Okay, take aniline. You can also react it with acetic anhydride. Okay, so let me take acetic anhydride. So let me take acetic anhydride. So what will be the reaction? What will be the reaction? So hydrogen of this NH2, okay, it is getting replaced by NH, C double bond O, CH3. One, so one of the molecule will be added, okay, plus CH3, C double bond O, OH. So acetic acid, okay. So I'm going to get N-phenyl and phenyl ethanamide. Okay, one phenyl ethanamide. That is acetanilide. Okay, the name is acetanilide. Is it clear? So what you have to remember in acylation, tertiary amines. Okay, tertiary amines, they do not undergo acylation. Primary. So I have taken the example of primary amine. Okay, this is a primary amine. This is a secondary amine. Okay, so tertiary amines do not undergo this acylation, only primary and secondary will undergo, because in tertiary we will not have any replaceable hydrogen atom, okay, which is bonded to the nitrogen atom, because here you have hydrogen atoms, right? So this can be replaced. But in when you see the tertiary, there is no replaceable hydrogen atom. So we are not using tertiary amine. Then when the amines, okay, we are are reacting with benzoyl chloride. Okay, what it forms? It forms benzamide. And okay, so that reaction is called as like C. This is a methenamine. Okay, react it with C6H5, C double bond O, Cl. So what will happen? React here. So this will polarize. You're going to get CH3, N, H, C double bond O, C6H5 plus HCl. So this is N-methyl, N-methyl benzamide. Okay, N-methyl benzamide. Okay, and this reaction is called as what? It is called as the benzolization. Okay, benzolization. Okay, it is undergoing benzoyl. So you're adding a benzoyl group. So it is a benzolization reaction. Is it clear? Yes, is it clear? So alkylation, acylation, is it clear? Okay. So these are very important reaction. Okay. Next we are going to see is the, so this what we have seen just now. Okay. So amines react with benzoyl chloride and this is called as benzolation. Okay. Next is carbalamine reaction. Next is the carbalamine reaction. So very, very important. Mark this important for 2 marks. 2 marks, very important. So primary amine, so this is a primary amine. Okay, we are heating with mixture of chloroform and alcoholic KOH. Okay, we are heating it with the presence of chloroform and your alcoholic KOH. Okay, and what it forms? It forms isocyanide. It forms isocyanide. Now, what is isocyanide? RNC. Okay, the alkyl group is bond through nitrogen. Okay, so it forms isocyanide. Okay, or they are called as the carbalamines. They are called as the carbalamine, and they are having very bad smell, foul smelling. Okay, they are having a very bad smell. So, primary amine that you can take aliphatic or aromatic primary amine, you are going to heat it with chloroform and ethanoic KOH and it forms your isocyanide or carbalamines. Okay, you are going to heat them. You are going to heat the chloroform and ethanoic acid. Okay, and what you are going to ethanoic potassium hydroxide, that is alcoholic KOH. Okay, you are going to get what? Isocyanide. Very, very, very important. And these reactions, carbalamine reactions, are only shown by primary or aliphatic or aromatic amine, not by secondary and tertiary amines. So secondary and tertiary amines, they do not undergo this reaction. Okay, they do not undergo this reaction. So let me give an example. So I will take R as CH3. So what will be the example? This plus alcoholic KOH. What I'm going to get? I'm going to get CH3NC plus 3KCl plus 3H2O. So I'm going to get methyl isocyanide. Okay, the name is methyl isocyanide. One more example with respect to, okay, with respect to aromatic amine. So let me take aniline. Okay, aniline plus CHCl3 plus 3KOH. What I'm going to get? I'm going to get NC. So this is phenyl isocyanide. Phenyl isocyanide plus 3KCl plus 3H2O. Okay. So remember that only primary aromatic or aliphatic amines will undergo carbalamine reaction. Secondary and tertiary will not undergo this reaction. Okay. Yes. So next is reaction with nitrous acid. Next is reaction with nitrous acid. So mark this also very, very important. Mark this is also very, very important. So what is happening here? So, okay. So aliphatic primary amine. Okay. So aliphatic primary amine, it reacts with nitrous acid. How this nitrous acid is formed? Okay. By using NaNO2. Okay. By using NaNO2 plus HCl. Okay, by using NaNO2 and HCl, I'm going to get what? I'm going to get So what we are doing here, we are taking a primary amine. Okay, we are taking a primary amine. We are reacting it with sodium nitrate and concentrated HCl. So when sodium nitrate and HCl react, it gives you nitrous acid, that is HNO2. Okay, it gives you nitrous acid, HNO2. So this HNO2 when reacts with your aniline, you are going to get disonium salt. Okay, you are going to get disonium salt. So suppose, okay, so this is aniline. Okay, so this is aniline reacted with nitrous acid. What I'm going to get? I'm going to get N plus Cl minus. Okay, so this is the reaction. Further undergoing hydrolysis, what will happen? I'm going to get OH plus N2 gas will be released. Okay, so this is the reaction. Okay, so this is the reaction. Is it clear? So amines, they react with nitrous acid to form disonium salt. Okay, to form disonium salt. So aliphatic disonium salt, these aliphatic disonium salt are unstable. So what it becomes, it undergoes hydrolysis and it forms alcohol and it liberates nitrogen gas. Okay, it liberates nitrogen gas. Okay, yes. So by using this nitrous acid, so here you can see, okay, so this is aniline. We are treating it with NaNO2 in the presence of HCl. Okay, what I'm going to get? I'm going to get this what nitrous acid. This nitrous acid, when it reacts with your aniline, I'm going to get your benzene disonium salt. So this benzene disonium salt, so possible with this reactions. Okay, if you use alcohol, I'm going to get a benzene with cuprous chloride. I'm going to get a chlorobenzene. With cuprous bromide, I'm going to get bromobenzene. With Ki, I'm going to get iodobenzene. Okay, I can use n number of reactions here. With this NaOH, I'm going to get alcohol. With HBF4, I'm going to get fluorobenzene. With copper cyanide, I'm going to get cyanobenzene. Okay, so like this. So these are the various reactions which we can do on the benzene disonium salt. Okay, as we know that N2 is an excellent leaving group. So all these reactions are possible. Okay, so remember how you get the benzene disonium salt, so aniline reacting with sodium nitrate in the presence of concentrated HCl. Okay, I'm going to get the nitrous acid. I'm going to get what? Nitrous acid. Is it clear? Is it clear? Okay. So the remaining reactions, okay. So there are a few more reactions. So, this one more thing to be added here. Okay, so this primary aromatic amines, okay, when they react with nitrous acid, okay, the temperature is 0 to 5 degrees Celsius. Okay, the temperature condition is it should be 0 to 5 degrees